Hello guys, welcome to this video. So today we'll be looking at polar coordinates. Now, a polar coordinate system, right, is a two-dimensional coordinate system in which each point on a plane is determined by a distance from a reference point and an angle from a reference direction. Now, the reference point is called the pole or the origin, and the distance measured from the pole is called the radius. Now, the positive horizontal axis is called the polar axis, and an angle measured from the polar axis, usually counterclockwise, is called the angular coordinate theta. Now, all what we have said here, all this story, is represented graphically as follows, right? So if I have a point on a plane, right, that point is with respect to a reference point called the pole. And then the distance from the point to the pole is called the radius. And then there's an angle measured, and now that angle is measured with respect to the positive horizontal axis called the polar axis. So if you measure an angle from the polar axis to touch the radius, you have formed what is called the angular coordinate. Now, it is worthy to know that a polar coordinate is written in terms of r and the angle formed with the polar axis. So, for example, I could have 5, 45 degree as opposed to 5, minus 5. So, and a coordinate of this form is Cartesian, right? Where having x and y. And a coordinate of this form is polar. Now let's look at the relationship between polar coordinate and Cartesian coordinate. Now this is the Cartesian plane, right? And we have a polar coordinate on it. Now, each point on a plane has a corresponding Cartesian value and a corresponding polar value, right? So for each Cartesian coordinate, there exists an equivalent polar coordinate. Now, as you can see on this graph, this is what the radius, right? And then the polar axis corresponds with what the positive x-axis of what the Cartesian plane. Now, from this diagram, it is worthy to note the following things. The value of theta, right? This angle formed drawing from the polar axis to the radius. Now, this angle formed in the four quadrants is as follows. So, in the first quadrant, the value of theta is what? Alpha. In the second quadrant, the value of theta is what? Pi minus alpha. In the third quadrant, the value of theta is what? Minus pi plus alpha. And in the fourth quadrant, the value of theta is what? Minus alpha. Now, you have to know all these things so you can solve problems relating to polar coordinates and the relationship between polar coordinates and the Cartesian coordinate. All right, so another thing you should know is this, that sine pi minus alpha is equals to sine alpha, and cos pi minus alpha is equals to minus cos alpha. Now let's see what we can do from here. So now looking at this diagram now, we can derive some certain things from it. So from your Pythagoras theorem, right? So we can say from Pythagoras theorem, r square is equals to x square plus y square. Therefore, r is equals to the square root of x plus y, right? So we have r here as the hypotenuse, we have y as the opposite to this angle theta, and we have x as the adjacent to the angle theta. So we have established this fact. Now, another thing you should know is from your trig ratios, right? From your trig ratios, tan y over x tan theta is equals to y over x, and sine theta is equals to y over r, and cos theta is equals to x over r. So from here, if we make y the subject of the formula, we have that y is equals to r sine theta. And from here, if we make x the subject of the formula, we have that x is equals to what? R cos theta. Right? Now, you know that the Cartesian coordinates are written as p, x, y. Right? Now, what do we say is x? X is what? R cos theta. So we can write this as what? R cos theta. And y is what? R sine theta. So we have established a connection between the Cartesian coordinate and the polar coordinate. Now let's look at some examples. So in example 1, it says, find the Cartesian coordinates of the point whose polar coordinates are A, 5, pi minus tan inverse of 4 over 3, and B, we have 5 root 2, pi over 4. How do we do this? Now remember that the link between the Cartesian coordinate and the polar coordinate is this, that the point xy is equals to what? R cos theta, r sine theta. So you have to take note of this. Now, from here, we can say that, okay, A, we have 5 pi minus tan inverse of 4 over 3. So from here, our r is equals to what? 5. And theta is equals to what? Pi minus tan inverse of what? 4 over 3. But now, this theta is in the form theta is equals to pi minus alpha. And we know that pi minus alpha is in what? The second quadrant. Right? So if this is in the second quadrant, it means that our alpha is what? The tan inverse of what? 4 over 3. Right? So from here, tan alpha is what? 4 over 3. Now, if we represent this on the Cartesian plane, it's going to look something like this. Right? So this is alpha. Right? So remember your SOHCAHTOA well. So tan will be what? Opposite over adjacent. So opposite is what? 4. Adjacent is 3. Now from Pythagoras theorem, you can find the length of this side, right? And that will be what? 5. You understand? So that's going to be 5. So from here, we can derive a couple of things. So we can say that sine alpha is what? Your opposite over what? Hypotenuse. So what's your opposite? 4. And what's the hypotenuse? 5. You can also say that cos alpha is equals to what? Adjacent over hypotenuse. What's the adjacent? 3. The hypotenuse? 5. So now that we have taken note of this, we can proceed to find what? The Cartesian coordinate. Now, we know that the Cartesian coordinate and the polar coordinate are related by this formula, pxy is equal to r cos theta, r sine theta, right? So, what's r? We said that r is 5. So, this is 5 into cos theta. What is theta? So that theta is what? pi minus alpha, cos pi minus alpha, comma, we have 5 into sine pi minus alpha, right? So from here, remember we said sine pi minus alpha equals to what? Sine alpha. And we also said cos pi minus alpha equals to what? Minus cos alpha. So that's what we're going to use here. So this becomes 5 into cos minus cos alpha and 5 into sine alpha. But sine alpha is 4/5 and cos alpha is what? 3/5. So we can say that this becomes minus 5 cos alpha, 5 sine alpha. And what is cos alpha? 3/5. So this is minus 5 times what? 3/5. And we have 5 times what? 4/5. So this leaves us with what? Minus 3 and what? 4. So this is what? The Cartesian coordinate of this polar coordinate. Now let's look at the second example. So we're having 5√2 and pi/4. So our r is what? 5√2, and then our theta is what? Pi/4, and that's equals to what? Alpha. So since it's alpha, it's in the first quadrant, right? So from here, we'll convert this from radians to degrees. So if you convert it, our alpha now becomes what? Pi/4. You just simply multiply by what? 180/pi. That gives you what? 45 degrees. Right? So once you have gotten that, you can say that r is equals to what? 5√2, and your theta is what? 45. Now we can now bring in the formula. Pxy is equals to r cos theta, r sine theta. Now what is r? 5√2 multiplied by cos theta is what? 45. And then we have 5√2 multiplied by what? Sine 45. Right? So from your trig ratios, you should know that sine 45 is equals to what? Cos 45. And they are both equal to 1/√2. If you don't know how we get this, you can get it from your unit square, right? Your unit square. So unit square has all sides equals to 1, and the diagonal equals to √2, right? So this √2 is gotten from Pythagoras theorem. Just square this side, find the square root, you have √2. Understand? So if this is your angle, this is your angle. Remember SOHCAHTOA, right? SOHCAHTOA. Your sine theta here, which is 45. Why is it 45? Because the angle in this square is what? 90. So if you divide it by 2, you have 45. So this theta is what? 45. So sine 45 is what? 1. That's your opposite, right? Over your hypotenuse. That's what? 1 over what? √2. So for cos theta is the same thing, right? So adjacent is what? 1. Hypotenuse is what? √2. 1 over √2, right? So when you substitute 1 over √2 into this, you end up having what? 5, 5. So that's 5√2 times cos 45, 5√2 times sine 45, right? 5√2 times 1 over √2, 5√2 times 1 over √2. So √2 cancels out √2. You have what? 5 and 5. So now, what if you were given the Cartesian coordinates to find the polar coordinates? Now let's look at the next example. Right. So in this example, it says find the polar coordinates of the point whose Cartesian coordinates are -2 and -2. Right. So what do we do from here? Remember the other formula. Okay, this is minus 2, right? Remember the former formula that said, the first formula that said, r is equal to what? The square root of x square plus y square. So this is your x, this is your y, right? So from here, r is what? The square root of 1 minus 1 minus 1 square, right? So from here we have r as 1 plus 1. Minus 1 square is 1, minus 1 square is 1. So when you add them, you end up with what? Root 2. But this is not all. We have to find the value of theta, right? But now, how do we find the value of theta from here? So what we do is this. So since the point minus 2 is in the third quadrant. Now, how is it in the third quadrant? Remember, we have 1, 2, 3, 4, right? So this is x, this is y. Now, the first number here is what? Minus 2, and it's what? A negative number. And this is what? A number on the x-axis. So that's probably somewhere here. On the y-axis, we have minus 2 again, somewhere here. So when you connect the point, right, is what? The third quadrant. Now, in the third quadrant, we have that theta is what? Minus pi plus alpha, right? So the value of theta in the third quadrant is what? Minus pi plus alpha. Now, how do we get alpha? Alpha is simply what? The tan inverse of y over x, right? And what is y in this case? So I have the tan inverse of y is minus 2 and x is what? Minus 2, right? So alpha equals to what? The tan inverse of 1, right? Now, if you punch your calculator, the tan inverse of 1 is what? 45. Now, if I'm to convert this to radians, it's going to be pi over 4. Now, how do you get pi over 4? We simply multiply this by pi over 180, right? So 45 here is 1 into 180 is what? 4. So you're left with what? Pi over 4. Now you have gotten your alpha. Now time to find theta. Theta is what? Minus pi plus what? Alpha. So that's what? Minus pi plus pi over 4. Remember that alpha is what? Pi over 4. So this now becomes minus 4 pi plus 3 pi. Sorry, plus pi, right? 4 divided by 4, 1 times pi, right? 4 divided by 1, 4 times minus pi, minus 4 pi. So we have minus 4 pi plus pi gives us minus 3 pi over 4. So this is what? The value of theta. So now, remember we said our r, we found r to be what? Root 2. And theta to be what? Minus pi over 4. So the point minus 2 is equivalent to root 2 comma minus 3 pi over 4, right? So this is the polar equivalent of this Cartesian coordinate. Now for the second example, we are having 12 and 5, right? So this is in the first quadrant. So let's quickly find r. So r is what? Root x square plus y square, right? So r is equals to what's x? Remember x, y. X is what? 12 square plus 5 square. So this is 144 plus 25. You have 169. And the square root of 169 is 13, right? So that's r. Now, since 12.5 is in the first quadrant, right? Our theta is what? Alpha. right? So we're not going to do much here. So now, how do we find our theta? First of all, let's find alpha. Alpha is what? The tan inverse of what? 12 over 5, right? So that is what? Alpha. Tan inverse of 12 over 5. So we leave it as this. We leave it as this. Now, we have found, remember we said theta equals to alpha. That means our theta is what? Tan inverse of what? 12 over 5. So you leave it in this form. Now, you can now say that 12, 5, the Cartesian coordinate, its equivalent polar coordinate is what? What's r? 13. And we have our theta as what? Tan inverse of 12 over 5. So that brings us to the end of this lesson. So just go over the video. Don't forget to like, subscribe, and ask your questions in the comment section. I'll see you in the next video.